Hello, I trained my version of ResNet today, but before training process, I want to show you something here. There's a slight problem in this line. I put a comma and 1 here, and I want to explain why. I just remove it now and check our result again from the previous video. If I feed this network with this tensor, I'll get 10 numbers as a result for 10 classes, which is okay, no problem on that. But the problem is if you feed this network like this, for example, for 2 images, okay, this network can't handle it. And as you can see, different shapes cannot be multiplied. But if you put a 1 here, then your result will be 220, 210. That means I have 2 images, and for each of the images I have 10 numbers, which is the right way. Let's change it to 1 again. Okay, 110, 1 image and 10 result. Let's proceed with training. Training my network, I use Fast.ai library because it's very easy to train networks with Fast.ai. A couple of line of code just enough. But also I use the dataset from Fast.ai library. ImageNet 160, smaller images, and only for 10 classes. It's a subset of ImageNet dataset for 1000 classes. It's smaller in image size and also number of classes. If you learn more, just click here. There's a link for dataset. First thing, I need to download images into my computer. It's very easy. Enter data, URL, and the name of the dataset. Then I need a container for my dataset, which I specify how I split the training and validation sets and transformations and resizing images if necessary, this kind of things. And data loaders based on this data block, which you again specify path, your path, dataset path, and batch size. In fact, in this point, we are ready to train. But first, check the number of classes, for example, data loaders .c for 10 classes here for verifying it. And if you want to look at your images in your dataset, let's say 12 of them, dlc.show batch, and 12, yeah, you can see 12 of your images. Then I need a new instance of ResNet. This is my implementation of ResNet for 10 classes, and it's here. As a last step, sort of, I need a learner that you specify your data loaders and model plus loss function here. Also type of metrics, accuracy or error, for example. This step is optional. In Fast.ai, there is a tool that suggests good learning rates for your data set. I don't want to explain LR find here, But if you want to learn more, you can click this link or the original paper that LR find based on. I think it is from Leslie Nielsen, Cyclical Learning Rates for Training Neural Networks. Yes. Let's switch here. Then I train my network with fit one cycle function in the Fast.ai. You only need to give a number of epochs here, and the learning rate comes from here. And the result is 72%, which is okay. But first, at my first try, that was around 62%. I know, and I want to explain why. First, I created a benchmark from PyTorch ResNet implementation and fit the images in it, and I got some results. It's around 74%. Same process here. New model, learner. I used the same data loaders but changed the name of the network. But the interesting part is not only difference between the suggested learning rate, but the shape of the diagram here. Check mine. It's jittery, right? But this one is very smooth. I guess this difference comes from how to initialize your network. Mine is just I just create my instance of ResNet right away, but I guess there's a process for initialization of PyTorch ResNet implementation. Probably the difference comes from there. I'm not sure. But the result was 74%, and mine was 62. And I compared these two implementations side by side. I find out that the linear channel bias was true for PyTorch, and mine was not specified at that time. I changed it, and my result became 64%. Then the convolution layers bias was false, and mine was not specified again. I changed it to false, then it became 65%. And this part is a bit tricky because in the original paper, let's see here. Okay, there is softmax at the end of the network, and I implemented that. But the result was 62%, so I removed it, and immediately the result became 72%, which is very close to benchmark. And in the, I'm not sure why we don't see a softmax in the PyTorch implementation. This is the PyTorch implementation of ResNet. If you check here, you don't see any activations. So I just removed from my version, and the result became better. So that was interesting. As a last step, no, before the last step, I trained the network for 50 epochs instead of 20 epochs, and the accuracy increased to 78%. And here I tried something different. I downloaded ImageNet 320 to my computer and trained this data set, trained with this data set, and the result became 82%. The difference between this and this is image size. In this version of dataset, The image size is around 320 pixels. So changing the image size helped my network to perform better. So and one more thing here, for the last part, I trained the network not 50 but 20 epochs. That means there's a big leap from here, 72 to 82, only by changing image size. It's very interesting to see this. All these experiments are here. You can try by yourself. I put the link of this notebook into the description. And if you have any comments, please share under the video or in my blog. And thanks for watching my video.